Very good evening, one and all. Thank you for joining. I hope if my voice is clear. If my voice is clear means can anyone put S in chat box? So very good evening to one and all. Thank you for your joining. Thank you for your presence. If my voice is clear now, can anyone respond in chat box? So Muhammad Tawfiq, hi. So Muhammad Tawfiq, hi. Aranamurthy, hi. Sir, somewhat lagging. So it's now correct. So it is now check once. Is my voice is clear? Yeah, clear, sir. To Muhammad Tawfiq, thank you for your response. Strinu, hi. Very good evening. To thank you for your presence. So I think is my voice is clear and I'm also stable, and then you can see my face. I'm visible also. I hope it's clear. Everything perfect, sir. Thank you for your response. So today we are gonna see a system Verilog. So introduction about system Verilog. Yesterday already we seen Verilog some basic code syntax. So that is enough to know the how HTL will work. So yesterday we seen some full adder code, and then we written some test bench and the design code to test the design code, and we seen some waveform window, and also we also seen waveform window and then transcript output. So today we are gonna see introduction about Verilog, so for system Verilog. So it's fully system Verilog are mostly used for verifications. Before going to that, just wait for a few minutes. Remaining people have to join. Then we can start. So very good evening, Radha Krishnan, Narayana Murthy, Muhammad Tawfiq, Bharata Singh, Manasa. Thank you for your response. So before going to that, how many people are aware system Verilog? So how many people are heard about system Verilog? Why system Verilog we are using? So what is the purpose of system Verilog? How many people are know the system Verilog? If you guys are know means just put yes in chat box. Then I can know how many people are aware of this. Nearly 46 members is there is in the live. So just put S in chat box if you guys are know the system Verilog. Now it's clear. I'm here about little, but okay, Tawfiq. Oh, thank you for response. So don't worry, we will see briefly, elaborately in this Saturday masterclass. This Saturday masterclass is fully based on system Verilog only. Okay, not a Verilog. We are fully focus on system Verilog. So we'll write some test bench code, and then we'll write some design code, test bench code, and then we will see some test bench architecture in system Verilog. I think it's alternative or Verilog. So it's not an alternative, it's an advanced version or extended version of Verilog. So basically system Verilog is a extended version of Verilog. So it has system Verilog having some features over the Verilog. So don't know. So Nagajodi, don't worry, we will see in the master class. So Ahmad Chandra Naidu, very good evening. Thank you for your joining. So I think I don't know, sir. Don't worry, we'll associate you driven. So don't worry, we will see in the charity master class. So enhanced version of Verilog, yeah. Enhanced version of Verilog is system Verilog. There are main features of Verilog main features of system Verilog over Verilog is system Verilog having a lot of features like a OOPS concept. There is a class in the system Verilog, and also there is an assertion, coverages, constraints in system Verilogs. These things like a class, coverage, constraint, these are the topics. These are the main thing in system Verilog we are having. So why we are having these kind of things means by using this we can verify the design code very easily. So how means we can easily write a design code by using Verilog. To verify that design code is very hard thing. Why? Because of yesterday we also seen full adder code. So we are designed full adder code in very simple line. As in by using two assign statements we can we can design the full adder logic. But to verify that we need to write n number of lines. We need to write n number of lines of code in system in test bench. So verification process is very hard compared to the design code. So designing of logic for particular chip is it is also very hard, but it is a simple way we can easily achieve that. But verification is a more harder than design. So in the first day, second day also I said no. So for one design engineer, we need 4 verification engineer. Okay, this is a current scenario industries are working. So we need more verification engineers. Okay, then only we can tape out the chip. Tape out is nothing but one full completed chip. Okay, so sir, I can't see your video. Just a minute. I think some network issue in my place. Just a minute. Is it clear now? Is my voice is visible? Is my face is visible? AV is okay, sir. Yeah, now it's clear. Thank you for response. So coming to the point, SystemVerilog having a lot of features. Let's see one by one how SystemVerilog helps for verification. So why? Because of yesterday we also seen test bench code for just a minute. So yesterday we written some code for full adder code. So I just opened that to give some explanation about what is test bench. So yesterday we written this only test bench code. So this is my design code. This is my design code means RTL code for full adder logic. Okay, it is very simple. It having very less number of lines. But you can see here in the test bench we are writing n number of lines to verify the design code. Why? What main purpose of writing test bench is to verify the design code whether it is working correctly or not. How we can verify means we can pass the stimulus. We can pass inputs to my design code by using this. Here you can see here I am passing the inputs for my design code. So this is how we are testing the design code by writing the test bench. Okay, but while dealing with the test bench, we need n number of lines. We need more time to write the code, test bench code, in a classic Verilog method. If you are using only Verilog for verification means you need to spend lot of time to verify the design code. But in SystemVerilog we can reduce the time. How we can reduce the time means it having the class concept, oops concept. By using that we can reduce the time. So let's see, we will see one by one how we can reduce the time. So what are the features it having, and also this is the main thing. By using the SystemVerilog we can easily verify the design. Why? Because of class is kind of one packet. Inside the packet we can put the data, and then we can do randomize, we can do constraint in the SystemVerilog. So we can easily verify our logic, we can easily verify our design code. This is the main thing of SystemVerilog. Okay, so let's see one by one. So let's see one by one topics in SystemVerilog in upcoming days. Okay, so till now it's clear for you what is the main purpose of SystemVerilog is to verify the design code at very fastly. Okay, this is the main purpose of the SystemVerilog. So Muhammad Tawfiq, everything is perfect. Thank you. So Jax, thank you for your joining. Varalakshmi, very good evening. So we'll see one by one. So SystemVerilog we can use for write the design code. We can write the design code in SystemVerilog, and also we can write the verification code in SystemVerilog. This is a two added features in Verilog. Okay, so in order to verify that a hardware description in HTL is correct, there is a need for language with more features in OOPS that will be support complicated testing features, and it's often is called hardware verification language. So SystemVerilog we can call as HDL, hardware description language, and also we can call as called as a HVL, hardware verification language. Why? Because of we can do verification very faster in by using SystemVerilog language. Okay, I think it's clear for you. If you guys are understand at this point, means just put S in chat box, then only I can move for remaining difference. Okay, so what are the features it having in SystemVerilog? Means it having the constrained randomization. So randomization is nothing but, so every time for example this code, for example here I'm writing the input for my full order logic. Here I'm just written only one combination of inputs, but assume like you having the n number of signals, you having the 1000 signals. Here we having the only 3 input signal, but assume like in any SoC in chip it having n number of signals, maybe 1000 to 5000. That much of signals it having. So you human can't give the stimulus for each and every signals. Assume like you having the 500 signals, 500 input signal for one chip. It means you have to give the input for each and every signal, then only you can test your design code. So assume like if you are doing like this, means it is very hard to give the each and every input for the design. So it is very hard thing, and then it is a little bit impossible also. So on that time there is a feature in SystemVerilog we having is a randomization. So randomization is one kind of function. It will do automatically assign the it will automatically assign input for the signals. Why? Because of it will assign, it will pass the randomized stimulus. Randomize means we won't try to input each and every input signal for the signals. So it will automatically assign some values as a randomized. Okay, that is a main feature in SystemVerilog. So we have a randomization in SystemVerilog, so we can reduce the timing while passing the stimulus to design code. This is a main advantage in SystemVerilog. Constrained randomization. Constrained means we can customize, we can limit the randomizations. So in upcoming class, upcoming days, I will show you how do randomization, how do you constrain, how do you write the constraint in SystemVerilog. And then OOPS concept. So OOPS concept is nothing but it having some class. By using the class we can call the class at every part of your code. So assume like you having one packet of data, you having one packet, or you having one box. Here you can put the signals, you can put the signals into the packet or box. So you can call the box at everywhere, so you can take it the packet wherever you go, you can take it the packet or box. So this is the advantage of the OOPS concept. So we can use by using the class concept, we can put some logic over the class module. So you can call the class at every part of your code. So this is one advantages. Why? Because of without class you need to write a logic wherever you want, you need to write a logic at there. But if you are using the class method, means you can write the logic inside the class, and then you can call the class at where you want. So it is very simple way. Why? Because of you are just calling the logic. You are not returning a new leaf logic. Okay, you are not return each and every line of logic at where you want. But by using class, you can write the logic inside the class, and then you can call the class where you want. So while in the SystemVerilog, you are just calling the class. So we can call the class by a single line of code. So this is one of the advantage. It will reduce our time of writing code. Okay, this is also this is advantage of OOPS concept, OOPS support. Okay, and then assertion. So assertion is also a very big topic in SystemVerilog verification. So it will give some rules and regulation for verification. So I will show you one by one. If I start this assertion, means it will very difficult to understand. So and then narrow gap between design and verification engineer, and then coverage support. So coverage is also one topic in main topic in SystemVerilog. While doing verification, we are doing randomization. Okay, we are doing some randomization means, and then we have to limit the randomization, and then we have to check whether it is randomized or not. So how we can check means, by using this coverage we can check whether it is randomized or not. So by using the coverage we can check like that. Okay, So and then new data types, for example logic. So in the Verilog we having the two data types only. One is reg and then wire. So net data types and then rich data type we having in the Verilog. But in the SystemVerilog we having the lot of data types like a logic, bit, byte. So these are the added data types in the SystemVerilog. Okay, this is one advantage of SystemVerilog over Verilog. Okay. So in Verilog random U random benches is there. What is the difference? So I can Vamshi Krishna Rajpati. So in Verilog also we it having the random U random, but in the SystemVerilog we having the randomized function, post randomize, pre randomize, and then we can randomize the whole class. So for example, assume like you having the n number of signals. Assume like you having the 500 signals. You can put into in class. So you are written the you are you are written the class, you are written the signals inside the class. Okay, the class having the 500 signals, 500 input and output signals. So you can easily randomize the 500 signals by randomize the class. Okay, you can if you randomize the class means that 500 signals also randomized. So this is one advantage over the Verilog. In the Verilog we can't do that. So we can do only randomize each and every signals one by one. We can't do the bulk randomization in Verilog, but we can do the bulk randomization in SystemVerilog by using the OOPS concept. I hope it's clear for you, Vamsi. So dear participants, kindly check your network. So it's loading, not visual. So and then more facts. So just check your internet connections, then we can watch. So and then let's go to the easy C model integration. So SystemVerilog and Verilog also, it's based on the C syntax. So mostly similar with the C. So and then this is the difference between the Verilog and SystemVerilog. So Verilog is a design entry and then module verification only. But in SystemVerilog we having the module level design and then gate level simulation and then system level verification and then unified language to span almost entire SOC design flow. So entire SOC design flow means by using SystemVerilog we can make the system level verification and then system level design. So means the SOC is nothing but we are using mobile phones. Each and every mobile phones having chips. That chips are comes under the SOC type chips. Okay, it's like a system on chips. So each and every system on chip it having the GPU, CPU, memory part, DMA, and then DSP block and then modem. These all components are inside only in the single chip only. So inside the single chip it having all these components. Okay, assume like that. So it means assume like how many IO pins it having. So CPU having some IO pins, GPU having some IO pins, DMA and then Intel and then flash memory, cache memory and then modem. So each and every block, every components having some input and output signals. If you count means it will count up to 10,000 or 5,000. That much range of signals we are dealing with in SOC. So we can easily design and we can easily verify this SOC kind of thing by using SystemVerilog. Why? Because of it having class concept, so we can easily verify that. Okay, this is one of the advantages of SystemVerilog. So we can do design and verification of SOC level. Okay. So and then this is the difference between the data types of over Verilog and SystemVerilog. So in the Verilog we only having the reg and wire, like net data types and then wire data types. Net data types and then reg data types. And then it having reg and wire, it's a 4-state data types. It means reg and wire it may be having the 0 we can, and then it may be having 1, it may be having x, it may be having z. So this is a Verilog data types and then it's the data states of Verilog. So in the SystemVerilog we having the added data types like a logic, byte, bit, integer, int and then long int, short int. So we having the n number of data types in the SystemVerilog, but in Verilog we having only 2 data types, reg and wire. Okay, that 2 data types are having the range of 4 states. 4 states is nothing but 0, 1, X and Z. So and then in SystemVerilog we having the 2 state data types are we having, and then 4 state data types also we having. So in the SystemVerilog, so this is one added features of SystemVerilog over the Verilog. Oops concept again. So demonking. So OOPS concept is nothing but a class object oriented programming concepts. So it will be fully based on the class kind of things. So we will see one by one in upcoming days. So I can't explain the OOPS concept here now itself. Why? Because of we will see some difference between the data types over the Verilog and SystemVerilog, and then we'll move one by one topics. So and then this is also one hardware specific procedures. In Verilog we having only having the always block, then initial begin block. But in SystemVerilog we having the always flip flop, always comp, always com means always combinational, so always latch. So these are the blocks, procedural blocks in the SystemVerilog. So in Verilog we only having the always block, always at passage of block. But here we can declare separately. If you are dealing with the sequential logic means you can use always flip flop, or else you can use always latch. If you are dealing with the combination logic means you can use the always combinational block. It is comes under the procedural block in SystemVerilog. So this is one advantage of SystemVerilog over Verilog. So and then till now you guys are getting. So and then if you guys are really interested in this masterclass, you can convert this masterclass into 1 month internship on advanced VLSI design and verifications. So these are the benefits you will get at the 1 month of internship program. So you will get the recorded sessions. Now you are not getting the recorded sessions, but if you purchase this internship means you will get the all the days recording sessions, and then you can access that recorded sessions up to 180 days. Okay, it's literally 6 months. And then you will get you can download all the PPTs, source codes as we are given, and then you will get the exclusive 4+ projects, and then you will get the confirmation letter from IETE, and then we are providing the weekly live sessions, and then we are providing also task for the live sessions and then weekly tasks, and then we are providing also academic internship report. It is very useful for while you are studying in college means it is very useful for you. And then you will finally get the internship certificate letter from IETE. Okay, these are the benefits you will get. The internship benefits, you will get these internship benefits at just discounted fee of just 999. Our regular fee is 499. In this masterclass period we are giving discounted fee as just 999. By using this link you can get this internship program, and also you will get the link in chat box. After clicking this registration link you will see this window. So and then you have to fill this form like a name, email, WhatsApp number, department, and then institution. Here in the domain sector, in the domain side, you have to choose advanced VLSI design and verification. Then only you will get this internship program. Why? Because of we are providing lot of internship program like all the domains like EV, IT sector, and then embedded. So we are providing all the internship program. So you have to choose this particularly advanced VLSI design and verification. Then only you will get, and then you will get this certificate at the end of 1 month. After completing the 1 month of internship, you will get this certificate from IETE. This is a sample certificate, looks like that. So these are the benefits you will get. You are getting from internship. That is recording sessions, LMS access, and then PPTs download. You can also download, and then you will get the exclusive 4+ projects. Okay, and then you will get the academic report. So these all things will get by the discounted fee of just 999. By using this link you will get. Okay, so and then let's move into data types. Okay, this is the data types we have in the SystemVerilog. So it having a lot of data types like a bit, byte, short int, long int, logic, reg, integer, time, and real. So where also we can include in the SystemVerilog data types. So the main thing is we having the data type like a logic here. We can see here logic. So you can see this logic. So logic is only one super auto data type of SystemVerilog. Why? Because of while writing in Verilog, we are declaring some signal, means whether you can use reg or whether you can use wire. So if it is a signal, if you are dealing with the combination logic, means you can use the wire data type. But if you are dealing with the sequential logic, means you have to use the reg data type. Okay, but every time you maybe get the confusion whether I can use reg or wire. But in SystemVerilog we can use the logic data type. It can do both. It can do both logic kind of thing. It can do both wire data type kind of thing. So the combination of the reg and wire is the logic data type in the SystemVerilog. So this is the most advantage of data type over the Verilog. In SystemVerilog we having. So logic data type is one data type. It can do both reg kind of thing and then logic kind of thing. So not wire kind of thing. So the logic data type is a combination of reg and wire. Okay. So this is the basic data types we having in the SystemVerilog. So this is very important. So we are writing the logic for hardware description language. So we are writing only for hardware. So each and every line, each and every signal is very important. Okay, why? Because of you are writing the Verilog code. That code you are writing the SystemVerilog code. That code will convert it into the gates. So that gates are built in the chips. How we can build means by using the transistor we can build into chip. So it means if you return some unwanted logic, very complex logic, means definitely it will take more n number of gate circuits. So it will take some more space. So it will increase our hardware size. It will increase our chip size. So we have to aware, and then we have to smart while writing the Verilog design code or SystemVerilog design code. Okay, we have to focus only on how to reduce the gates, how to reduce the circuit. But main thing is ultimate goal is we have to achieve our goal, we have to achieve our design. But in the way of we have to reduce the circuit size, logic gates circuit size. Okay, this is one main thing of writing design code. So these are the benefits in SystemVerilog we having. So we having a lot of data types here. So bit, byte, short int, long int, and then you can also see here states. States is nothing but that particular signal. If you register one signal with data type of bit, means it can have it can do operation. It can store only the two state. It may be 0 or 1. 2 state means is nothing but 0 or 1. 4 state means it may be that particular signal can perform with the zeros, may can perform with ones, may can perform with x, and then may can perform with z. Okay, x means unknown, z means high impedance. Yesterday also I said we seen that the definitions of states. So 4 state means nothing but 0, 1, x, and then z. 2 state is nothing but 0 and 1. Okay, so each and every data type having some state, size, sign. Sign is nothing but signed or unsigned. Signed means it can do perform negative also. But unsigned means it can do only the positive integers. So it means by using this, like for example, if you declared one signal by using this byte or int. So int is signed in nature, so it can perform the negative operations also. We can assign the negative values for that particular signal if you are using the int data type. But integer, so integer also signed. But if you register a signal with the logic data type, means you can't assign the negative value. Why? Because of it is unsigned in nature. Okay, so logic is unsigned in nature, and then reg is also unsigned in nature, byte is also unsigned in nature. So it means we can assign the value only positive value only we can assign to my bit, reg, and then logic keywords. So that are data types. So and then we can also override the, so if and then you can see here logic is unsigned in nature, but we can assign as a signed. How we can means implicitly we have to write the signed keyword in before the data type. Okay, then only we can assign like a signed. So basic thing is you have to know this, you have to know all these states, size, and then mode of and each and every data types. Then only it is very useful while writing the SystemVerilog code. Why? Because of, so we have to assure that, so which data type we have to use for particular signal. for particular signal, it's need only two state only. For particular signal, it's need four state inputs. Okay, and the time we have to know, we must know. So which data type having two state, which data type having four state, then only we can proceed with code. So byte having the two state, the size is 1 bit, so either it can be 0, it can be 1. And then bit. So and then byte, so byte means 8 bit. So 8 bit means the width of the data type is 8 bit. It can store 8 bit of data, it can perform 8 bit of data. The state is two state, it means we can store only zeros and ones in the 8 bits. And then short int also 16 bit, the state is two state, it may be 0 or 1. And then int is 32 bit. So if you are dealing with integer, means int means the width of the int is 32 bit. So for example, int a, it means the particular a signal, it having that we can store the 32 bit of data. Okay, and then it's signed in nature. So and then long int 64 bit, and then two state it having. And then logic, user defined. So user defined is nothing but we can increase the width, like a logic a, and the square bracket we can write like a 7120, means it having the 8 bit of width. So we can, it is an user defined, so we can increase and decrease by using the logic data type. So and then the reg, so reg is also one data type. So it is a 4 state. You can see here logic and reg are 4 state. It means it can be 0, it can be 1, it can be x, it can be z. So and then you see it is also user defined. And then integer, so integer also 4 state, 32 bit, and signed in nature. But you can see the difference between int and integer. So integer is a 2 state, sorry, int is 2 state, but integer is a 4 state. Okay, and then time 4 state, 64 bit, unsigned in nature. And then real is a floating point, 2 state. So and then it having some bit is 32 bit size, I think so. And then it is a unsigned in nature. So these are the data types you having in the SystemVerilog. So firstly, we should memorize, or we should understand these data types. This is very important. As a VLS engineer, data types very important. Okay. So and then operators in Verilog. And Verilog and SystemVerilog are same only. So these are the operators we having in the SystemVerilog, and also we having in the Verilog. So till now you guys are clear? Are you getting my point? If you understand, means just put S in chat box, then only I can move into remaining topics. It's loading, sir. So it's loading only. I think it's now clear. Maybe there is a network issue from your side or my side. I think it's now clear for you. So operators in Verilog. So main thing is we know that addition, subtraction, multiplication, division. The double star means it is a power. Okay, and then relation less than or equal to, greater than like equal to. I think you people are aware of this. And then this is the main thing. Double ampersand symbol. This symbol is refers to logical operation. This symbol is refers to logical AND. This symbol is refers to logical OR. This symbol is refers to logical NOT. If it is this means logical, it's not like a logical. This approximate symbol is known as bitwise NOT. And then this is a bitwise OR. And then this is a bitwise AND. If you are using double, means it is a logical AND, logical OR, logical NOT. And then logical equality, this is a logical inequality, case equality. So there is a difference between the logical equality, case equality. So logical equality is nothing but it will see only the zeros and ones, two state only it will see whether it is equal or not. But in the case equality it will see the four states, 0, 1, x, z. So in the case equality it will see the 3 states. Okay, and then this is a case inequality, and then modulus. So and then main thing is, if you use the modulo symbol in your design code, it means it is not synthesizable. So and there is a synthesizable and the non-synthesizable in the design code. While writing the design code or RTL code for some particular design, for particular logic, for particular chip, means that code must be in the synthesizable. So synthesizable is nothing but if it is synthesizable only, we can convert the Verilog code, SystemVerilog code into gates. If it is not synthesizable means we can't convert into the gate circuit. So if you are written this, if you are using this modulo symbol in your design code means this symbol is non-synthesizable, you can't convert the code into gates circuit. Okay, so the main thing is your design code must be in the synthesizable. Okay, while dealing with the verification, we can use a non-synthesizable functions and then operators. Okay, and then this is a concatenation operator, this is a conditional operator. So yesterday we also seen like a ternary operator. So if it is true means it will choose this, if it is not true means it will choose another one. So this all comes under this conditional operators. So and then bitwise or bitwise not, bitwise XOR, bitwise XNOR, reduction and reduction or, reduction NAND, reduction NOR, reduction XOR, reduction XNOR, left shift, right shift. So reduction is nothing but it will do something, so I will show you one by one. So these all operators, it is if you want to familiar with this operator means you have to practice with your own writing of code, one writing of any design code or verification code, but you have to use this code, then only it will very familiar for you. It will be very familiar for you whether you practice these codes, whether you practice this kind of operators in your code. So and then structural data types, we will see brief explanation about these data types. Okay, so wire drives the values, wire is S. So default value of wire data type is Z. So and then we know that each and every data type, every data type having the some default values. So the wire means the default value of the wire data type is Z. So and then reg, so default value of reg data type is X, unknown value. So and then logic 0 1 x z. Okay, so integer, it means integer is a signed in nature, it can perform with the minus 2312 plus 231, and then real 64 bit, and then real float 1 point is a floating point time 64 bit. We yesterday also we seen the time data type. So and then parameter also we seen yesterday. So and then two state data types. So these are the two state data types, bit, int, byte, short int, long int. So these are the two state data types, means it can be 0 or it can be 1. It can't be as X and Z. So this is the two state data types we are having in the SystemVerilog. So and then void data type, string data type. So string is one data type also we have in SystemVerilog. We can use like this, string equal to within the double quotes we can write the anything, we can write the number, we can write the letters inside the string. So event also one data type here we have in SystemVerilog. It is used for triggering. So how it is work means, if you are written some code for with always block, always at passage of clock, it means always at, if the passage is occurs means that always block will execute, will do something, whatever written inside the always block it will do that. So it means what we are doing that means we are triggering. So the always block will always looking for triggering element. The triggering element is nothing but always passage of clock. If the passage is occur means it will execute the block. Same thing we can add the triggering element at the code in the SystemVerilog. So we'll see the event in one by one session in the upcoming sessions. And then user defined data types. So type def is also one kind of advantage in the SystemVerilog. Type def, enum, enumeration data type. Enum is also one important data type, not data type, one important functionalities in SystemVerilog. So there are a lot of advantages in the SystemVerilog over Verilog. Why? Because of Verilog having only reg and wire, but in SystemVerilog having a lot of data type, a lot of functions like a void, string, and then type def, enum. So and then even triggering. So it having a lot of functionalities in the SystemVerilog. Okay, so let's see one by one. So firstly we'll see the enum. So before going to that I will write one code, so then only you can easily understand. So what is the default value of data types? Okay, I will use EDA playground, and then before going to that we are going to use mentor graphics Costa sim. So I will show the tool here, mentor graphics Costa sim. So this is a tool we are gonna use. uh, the tool look like this symbol. So this the tool look like this only, Costa Sim advanced verification. So you can download, so you can't directly buy. Why? Because of it will ask some money. It is a paid tool, so you can't get free. So if you are college students, or by using the institution ID will get the free. But if you're a normal person, you can't get that free, so you have to pay for that tool. But you can download the tool in the Get Into PC website. So Get Into PC. So in this is one website, you can download some cracked versions of tool. So you can search over here mentor graphics Costa Sim and then try to install. It is very simple way. And then in the website also they are showing how to install, step by step guidance they are given also. Just type Costa Sim here and then you will get the tool. You can see here mentor graphics Costa Sim 2024 free download. Just click that link and then you have to follow the step by step procedure and then you can install, which is very simple only. And also in the YouTube also there are a lot of reference videos. So if you search the Costa Sim Costa Sim installation, means you will get some reference video. So and then follow that rule, follow that video, and then you can easily install. Why I'm not showing means, why? Because of it is it is a cracked version. If I do means there is some consequence I have to face, then only that's why I'm showing. So I'm just saying to you, so install yourself. It is very easy step, and then you can watch YouTube videos to install the Costa Sim mentor graphics Costa Sim advanced verification. This is a tool. Then the tool name is this only, mentor graphics Costa Sim. Okay, this is a tool we are gonna use. Please try to install, then only you can do practice in upcoming days. Okay, I'm going to use that tool only upcoming days, Costa Sim. So and then why I'm doing this means, so I will just write one code to see the default value of my SystemVerilog data types. Okay, I'm going to use a EDA playground. So and then please try to install that particular Costa Sim tool, then only you can try the coverage constraints and then lot of things in SystemVerilog. Here also you can write the SystemVerilog code, but at coverages constraints that we can't do here. Okay, we can do only in the tool only. So in the tool only we can do the constraint operation, assertion operation, randomizations, and then we can see the clear waveform window in the tool only. So and then in the Xilinx or Vivado are not having the UVM and then coverage kind of things. So in the Xilinx, Vivado, Intel Cortex RAMs are only for FPGA development, only for FPGAs. We can write the design code, we can write the test bench, we can do simulation, and then we can implement into hardware. But here we are dealing with the verification, SystemVerilog verification. It is advanced topic, so that particular Xilinx Vivado tool won't use for you. Why? Because of it is only for FPGA. Okay, I think it's clear for you. So here I am written some SystemVerilog code. So module here, my module name is my module name is like a just random name. So RAM demo, this is my module name. So here I didn't give any port list. Why? Because of I'm not going to write any design code. I'm going to write only test bench code. I'm going to do only simulation. For that we don't need there is no necessary to give the port list. If I didn't give any port list means there is no input and output pins in my design. Assume like that. Okay, so here I will use firstly reg. This is my declaration of the reg data type. By this is a signal name, internal signal. If I created here means it is known as internal signal. Okay, if I created the signals here inside the bracket, inside the port list means that is a main signal. Okay, that is a main signal, IO signal for my circuit, for my logic. So and then this if I created here means these internal signals, okay, and then wire. So I'm going to show you the default values of data types. So and then these two comes under the Verilog. We can also use these data types in the system Verilog also. And then I will write the logic. This is a system Verilog data type, okay, and then bit. So and then byte. So and then integer int. So I just creating my internal signals. This is a data type, signal name is A, data type, signal name is B, logic data type, logic is data type, signal name is C, data type, signal name, data type, signal name, data type, signal name, okay, and then long int. Short int. And then what we have, logic int, byte, and then integer. So and then let's I think we're mostly these we're gonna use mostly this data type only. So okay, this is very main data types in system Verilog we are gonna use. So I just created the signals, okay, and then I'm going to simulate. So how we can simulate means, if simulation will start from initial begin only. So we have to write the initial begin, then only it will do simulation. Initial begin end. So here I'm going to display, while after the simulation I'm going to display the default values of my data types, okay, $display. So okay, and then reg. So firstly I will display the reg data type. What is the default value of reg data type? So reg, I want to see in my binary. So reg equal to binary. So and then here A. So and then I just copy this. I will write I just copy. So I'm using display statement $display here edge, and then another data type is wire in the wire signal name is B, caps B, and then logic. So I want to see logic default value. So and then bit signal name is D. So and then byte signal name is E. So and then int signal name is F. So and then long int signal name is G. So and then short int signal name is I. So and then integer signal name is J. So if I run this means I will get the default values of data types, reg, wire, int, integer, okay. I just save and run this. Before going to that, you have to choose a tool here, simulator tool. I'm going to use CostaSim, okay. I choose the CostaSim, Simon's CostaSim 2024 version. Save and then run. So my software name is nothing but CostaSim, QUESTASIM, CostaSim Mentor Graphics. Mentor. This is a tool, Mentor Graphics CostaSim, okay. mentor graphics costasim. So you can refer the YouTube, so how to installation process. You can get into YouTube also. So I can't show here. Why? Because of it is a cracked version. So in the Siemens is a company are providing the costasim. If you click this link means it will ask money, so it is a paid tool, not a free tool. So and then here also you can buy that tool products, verific simulation, free verification simulation. And then there are a lot of versions, Costa 1 SFE, but Costa sim formal verification. And then if you and then click here, so you can download the tool. So or else you can easily get the cracked version on YouTube. So just watch YouTube videos, so you can easily install the tool. So okay, because so I think it's clear for you, Naga Jodhiye. So and then you can see here I got my output. So this is a default values of data type. So default value is nothing but, so if I'm using this one data type, if I'm assigning some values. So for example, if I'm here a reg is a data type, a is a signal name. If I'm assigning a equal 5 means a equal to 1 means that value is assigned to the a signal. But if I didn't assign any value means what is the value of the signal? So that is the we are seeing in here. So this is a default value of data type. If I didn't give any values means the default value is this only. So reg having a default value of x, wire having a default value of z, logic having a default value of x, bit having the default value of 0, byte having default value of 8 bit of 0. Why means a byte is 8 bit is comes, it's known as 1 byte. 8 bit means it having the 1 byte means it having the 8 bits. So 8 bit of 0. So and then integer is 32 bit size. So I already shown you default size. So here you can see here. So size is also very important. Size of the data type is also very important. Okay. So and then why important means you can see the output. So you can see the output size. So integer is 32 bit of 0. This is the default value of integer data type. And then long int. So long int means 64 bit of 0. This is a 64 bit of 0 default value for long data type, long int data type. And then short int is 16 bit. 16 bit of 0 is the default value of short int data type. And then integer. So you can see here this integer is 32 bit of 0, but this integer is 32 bit of x. This is a difference between the int and the integer. Okay. And then that's all. We have written these signals only. Okay. This is and then if you are college students, if you are studying in college, you are looking for VLSI jobs means they will ask n number of interview questions regarding the data types only. Why? Because of they will ask difference between reg and wire. So what is the difference between reg and the wire? So reg, it's a reg reg is only using for, we can use for conventional sequential logic. Wire is useful for conventional logic. And then the main difference is a default value of reg is x, default value of wire is z. And then difference between the integer and int means default value of integer is 32 bit of x, the default value of the int is 32 bit of 0. Okay, this is a difference. And then what is difference between the bit and byte means 0 bit, single bit is a 0, and then byte means 8 bit of 0. So they will ask a number of they will ask some tricky questions in the data type itself. Okay, so data type is very important in the hardware side. If and same like in the embedded C and then C++, so are dealing with hardware means the data type is very important. So in this software side we are not focusing about much more about in data types, but in the hardware side, in the we are dealing with hardware, data type is very important. Okay, I think it's clear for you. So please tell me that software name, sir. So already said. So and then I think it's clear for you. So if you just do you guys understand the SystemVerilog data types? I think so. So and then Enum. So we're going to the we are gonna see the Enum here. So Enum is one kind of advantage in the SystemVerilog. So an enum type defines as a set of named values. The simplest enumerated type declaration contains a list of constant names and their one or more variables. It means, so I think it's a big topic, enum. So enum works like a parameter. So we know the parameter here. So I will show the usage of the parameter. So here I'm creating one parameter. So parameter b, so sorry, parameter z equal to 5. Okay, here we know that 32 int having the 32 bit of 32 bit width, so it can store 5. So I'm assigning uh, z over here. It means I'm assigning 5 to my signal f. Okay, so let's I print this. Let's see the output of int. Why? Because of, let's see the output of this. Why? Because of I am assigning the value of 5 to my f integer data type. Okay, f signal. So let's see the output. You can see here you can see a 32 bit of 101. So 101 is nothing but binary representation of the 5. Okay, 101 is nothing but binary representation of the bytes 5. So if I want to see in the decimal output, means I have to change here. If I change here d means decimal output, it will show the output in the decimal format. Okay, how that integer data type showing 5. So you can see here how that integer value, that particular f signal showing 5. Why? Because of I didn't assign any value for the f. I'm just assigning the z. So z having the 5. If I change here 10 means it will show 10. Okay, it will show the output as 10. This is a parameter working. Same like same like enum also. Parameter and the enum also slightly same. You can also see here the output is 10. I'm just overwriting my parameter, and then this is usage of parameters. You are using this z at everywhere of your code, so you have to use 10, so that you can easily make one parameter, assign the value for the parameter name, and then you can use the parameter name as you want. If you want to override the value of a parameter, means you can easily override here. You can't change each and every line. Why? Because of if you are using the z here means if you change here means it will automatically update the value. But in random, or if you are writing randomly like a 10 means you have to choose in every line of code 10 into 5, 10 into 5, 10 into 5. This is advantage of the parameter. Same like parameter functionality is enum also, but here, so enum, so here the syntax look like this only. Enum, inside the flower bracket we can declare a enum constants, red, like a variables. You can assume like a variables, red, green, blue, yellow, white. We can also name like a, b, c, d, or 1, 2, 3. Each and every constant having the enum values. Okay, enum values start from 0 and then it will update automatically 0, 1, 2, 3. So red having the 0 value, green having the 1 value, blue having the 2 value, yellow having the 3 value. So it will automatically increase. We won't give the values for the constants. It will automatically assign the values. Okay, and then this is a enum name. By using this enum name, we can call the enum. Okay, we can use the enum. So this is a new topic, enum in SystemVerilog. We will see this topic tomorrow. Why? Because of it having a lot of concepts. If I take means there is no time, so we will see in this enum concept tomorrow. Till now, do you guys understand? Do guys any doubt? Means you can ask now. So rates and logic difference. So I will show you here. So yesterday also we seen one code here. You can see here in the test bench I return the system Verilog. I return the Verilog test bench. Here you can see here this is a Verilog dot v means a Verilog extension. So in the Verilog test bench input you have to use reg keyword. Output means you have to use wide data type. But if you are using system Verilog means you can use logic keyword for both input and output. That is a difference. In the part of use you are using reg and wire means you can simply use logic. So the combination of the reg and wire is logic. Okay. Sir, are the variables case sensitive in system Verilog? No. So variable is nothing. Here we can't say the variables. Here we have to say like a signals. Why? We are dealing with signals. We are dealing with hardwares. Here these are the signals: A signal, B signal, C signal, D signals, E signal, F signal, G signal. Okay. So and then IETE it's clear. Okay. Thank you for response. So Annamalai thank you. Yes. So if you guys are doubts means you can ask now. Okay. Please. So you please try to install that tool Mentor Graphics Costa Sim for verification. So I'm not, I can't store the installation process. Why? Because of it's a cracked version. So it is illegal to promote that. So you can watch YouTube videos and then you can easily install that tool. So I think this is for today. If you guys are any doubt means you can ask now. Aish or okay. If you guys any doubt you can ask now. So verification is very important thing. What should I use VS Code for Costa Sim? So VS Code is nothing but it's a tool. It is a text editor. So for example, if you are using the Notepad means so it only having less number of advantages. So you can write here. It will very black in color. You can't change the font color. But in System Verilog in the VS Code, we can see here color of the code, and then it have a lot of extensions. Extensions means nothing but System Verilog extensions. So in the extensions, after adding the extensions, you can see the colors, and then here you can easily access the terminal. Okay, terminal means it's nothing but we can control the computer by using the commands. We can easily access the commands. So why? Because of learning Linux is very important. Learning Linux commands is very important. In the industries, the companies are using Linux commands only. They are giving only the Linux OS to work with the employees. They won't use Windows, they won't use that. So they will use Linux, Ubuntu kind of things. So if you want, while using with Linux means you have to know the commands, Linux commands. But in the System Verilog we can easily understand that. We can easily use the Linux command here. So I will show the Linux commands. If I just put ls here means in my particular FA. So this is my local disk D. This is my folder. I'm just put yes here. Ls means list the file. So it will display the my files are inside my folder. So you can see here in my FA folder I'm having these files dump vcd fa.v run.2 testbench file transcript file. I'm having this file. So I can see here also in the terminal also I can see. So this is a advantage. Why this is a advantage of VS Code. We can use the terminal in the VS Code. I think it's clear for you. So and then from where can I install free versions EDA Playground? So EDA Playground I say also you will get. So how you can get means in the Chrome, just to open the EDA Playground website login page. So I have just already logged in. So I'm going to log out here. So you will see this window. You will see this window, and then you have to fill these details. but main thing is you can get the access, of EDA playground, whether you are working in company, or you can use your college email ID, or company email ID, or college email ID. So institution email ID only, by using the institution email ID only, you can get the EDA access. Okay, so this is the main thing. So it is also very simple thing. By using the institution or your company mail ID, you can access the EDA playground. Okay, I think it's clear for you. Thank you, sir. Thank you, Ani, for edits. Thank you. So I think it's clear for you. So thank you guys. Thank you for listening. We'll see you tomorrow.